everyone. So today's topic is we have to find energy eigenvalue and eigenfunction of a particle in one-dimensional infinite potential well using one-dimensional Schrodinger wave equation. So for the same, we consider a potential well which is of infinite height and finite width. The width of the well is A. So if we say the first boundary of the well, it is defined by x is equal to 0 and the second boundary by x is equal to A. So the width of the well is A and height of the well it is infinite. Now we consider a particle of mass m. Particle of mass m which is confined inside the potential well. Also what we assume that outside the potential well V is infinite and inside the well V is equal to 0. So if we write the boundary condition for V will be equal to 0 for x less than is equal to 0 and less than equal to A, and it will be equal to infinite for x less than 0 and x greater than A, means value beyond the potential, outside the potential well, the potential value is infinite and inside the well the potential value is 0. Now using time independent, we have to use time independent Schrodinger wave equation to solve the energy eigenvalue, means what is the energy of a particle and energy eigenfunction psi of the particle. So as we know, one dimensional time independent Schrodinger wave equation, one dimensional time independent Schrodinger wave equation, and we have already established that equation. It is dou square psi by dou x square plus 8 pi square m by h square E minus V psi is equal to 0. We have established the equation dou square by dou x square plus 8 pi square m by h square E minus V psi is equal to 0, where psi is the function, wave function, m is the mass, h is Planck's constant, E is total energy and V is the potential energy of the particle. Now we will consider two cases. In first case, we assume that the particle exists in outside the boundary. Let us see what will be the energy eigenvalue and eigenfunction. So case 1, and we know that outside the potential well V is equal to infinity. Now let us substitute this value in the above equation 1. So what we get? Dou square psi by dou x square plus 8 pi square m by h square e minus infinity psi is equal to 0. So, here what we see that we have to subtract the energy, we have to, here what we see that we have to subtract infinite value from the total energy value, and this is an impossible solution, and the only value of the wave function what we can evaluate is psi is equal to 0. For this equation, the only possible solution is psi is equal to 0. So, as I have already explained, if we get the wave function is equal to 0, means if psi is equal to 0, it means that particle does not exist. For particle to exist, psi must be equal to 1. So, psi is equal to 0 means that the particle does not exist outside the potential well. Now, let us go to the second case where we assume that particle exists inside the potential well. So, inside the potential what we know that V is equal to 0. So, let us substitute this value in the above equation 1, we get dou square psi by dou x square plus 8 pi square m by h square e minus 0 psi is equal to 0. So, further evaluating, if we subtract the value e minus 0, you will get it e. So, the equation is dou square psi by dou x square plus 8 pi square m by h square e psi is equal to 0. Let us assume that 8 pi square m by h square into e is equal to k square. So, substituting the value 8 pi square m by h square into e by k square, we get dou square psi by dou x square plus 8 pi square m by h square e psi is equal to 0 becomes dou square psi divided by dou x square plus k square psi is equal to 0. So, if we want to write the general solution for this equation 3, we get psi is equal to a sin kx plus b cos kx, where A and B are arbitrary constant to be determined. So, to find out the value of A and B, again we have to take two cases on the boundary, means we have the boundary first x is equal to 0 and x is equal to A. So, on this boundary what we consider that as psi is equal to 0 outside the potential we have evaluated. So, by the symmetry on the boundary also means exactly equal to 0 and x is equal to A, psi will take the value 0. So, we take the first case at x is equal to 0, psi is equal to 0. And when we substitute in equation 5, we get 0 is equal to A sin k, x you have to substitute is 0 plus B cos k, x is 0. So, what we get? A sin k into 0 is 0 plus B cos k into 0 is 0. So, what we know, sin 0 is 0. So, this value, the total, if you multiply 0 by A, it will be 0 and cos 0 is equal to 1. So, this suggests that B is equal to 0. So, this B is equal to 0, if we substitute in equation 5, this whole term B cos kx, as B is equal to 0, it will become 0 and psi will take the value A sin kx. So, substituting B is equal to 0 in equation 5, psi takes the value A sin kx. Now, we will take the second boundary, x is equal to A, psi is equal to 0, we get 0 is equal to A sin k into A. As the amplitude of the wave function cannot be 0, A cannot be 0, so what we take, sin ka is equal to 0. So, what will be the general answer? What sin, at what value of theta sin will be equal to 0. So, what we know, sin is 0 for 0, for pi, for 2 pi, for 3 pi, so on. So, we can write it as that Ka is equal to n pi, where n is equal to 0, 1, 2, 3 and so on. So, we get the value of k, that is equal to n pi by A. So, if this k value n pi by A, we substitute in equation 5, what we get, psi is equal to A sin k is equal to n pi by A into x. So, this is value of psi we have to still find out the value of A, and we will do it later. This psi is an eigenfunction. Psi is an eigenfunction which is equal to A sin n pi by A into x. Now, if we substitute the value of n is equal to 0, then what we get? Psi is equal to 0. So, this n is equal to 0 is not an acceptable value. Whenever we start the substituting the value of n, then we start from 1 to 3, as these n value represents the energy levels. The n value represents the energy level, and here as it is n, we also put it in the subscript of psi, it is n. Now, n is equal to 0 is not an acceptable value. So, we will start the value of n, we will take the value of n is that 1, 2, 3 and so on. Now, as we know Ka is equal to n pi by A, we have substituted for K square is equal to 8 pi square m by h square this into E. This is the value of K square. So, what is K now? It is n pi by A whole square, and this will be equal to 8 pi square m by h square into E, and if you solve for E, you will get it n square h square by 8 ma square, as it is n, so subscript will put it n, and the energy eigenvalue equation we get it n square h square by 8 ma square. Here if you solve it, you will get it, when you square it, n square pi square by a square, pi square cancels out. So, further if you cross multiply it, E will be equal to n square h square divided by 8 m a square. So, we have E n is equal to n square h square by 8 m a square. Already I have explained it, n is equal to 0 is not an acceptable value. As for that, psi will also take the value 0, means particle, it is understood that at psi is equal to, if psi is equal to 0, the particle will not exist inside the potential, which is not an acceptable solution. So, we'll take the value of n, that is equal to 1, 2, 3, and it represents the energy state, energy level. N is equal to 1 is the ground state, n is equal to 2 is the second energy level, and we represent it by first excited state, and n is equal to 3 is the third energy level, and we represent it by the second excited state, and so on. Now, let us see if we take the value n is equal to 1. N is equal to 1, we get E1 is equal to h square by 8 ma square. 1 square, it will be 1 itself, so you will retain it h square by 8 ma square, and let h square by 8 ma square be represented by E naught, and this is the energy value of the ground state energy level, which we also call it as 0 point energy. Now, if we take n is equal to 2, n is equal to 2, which represents the second energy level, means the first excited state, we get E2 will be equal to 2 square h square by 8 ma square, and 2 square is 4 and h square by 8 ma square is the value of E naught, 0 point energy. If we take n is equal to 3, then E3 it will be equal to 3 square h square by 8 ma square, and this is will be equal to 9 E naught, and so on. So what we observe from here, as we have explained it, that in quantum theory or quantum physics, if you take the energy value of a particle and if you come from bottom to top, the energy, you can divide the energy into different sub energy levels, and we say that in the energy of a particle is discrete in nature, as the energy of the particle is quantized and hence discrete in nature. So what we can say, that in the bound state, the particle energy so in the bound state, the particle energy is discrete in nature, that is quantized, means each energy level has its own energy value when the particle is in the bound state. So next, we have seen in the previous equation that psi is equal to a sin n pi by a into x. Now what we have to do, we have to find out the value of a. So in the function psi n, that is equal to a sin n pi by a into x, if we have to find out the a, which is the amplitude of the wave function, we have to consider the situation where the particle exists inside the potential well, and if it is the particle exists inside the potential well, then within the boundary x is equal to 0 to x is equal to a, the normalization of the wave function psi square, that will be equal to, that will give you the value equal to 1. Means if the particle exists inside the potential well, the normalization of the wave function, it will be equal to 1. Now we will substitute this equation over here. So what we get, it is equal, x is equal to 0 to x is equal to a square sin square n pi by a into x dx, it will be equal to 1. As a square is constant, we will take out of the integration, we get it sin square n pi by a to x dx, it will be equal to 1. So now this sin square n pi by a into x, to integrate this we have to further simplify the sin square theta value, and what we know that sin square theta is equal to 1 minus cos 2 theta divided by 2. Sin square theta is equal to 1 minus cos 2 theta divided by 2. So, simplify further sin square n pi by a into x value, what we get? One minus cos of 2 n pi by a into x dx, it will be equal to 1, and we have to divide the whole value by 2. 1 minus cos 2 theta by 2, so it is 1 minus cos 2 n pi by a into x. Now further we'll integrate it by parts. If you multiply 1 into dx, you will get dx minus you will get a square by 2, it is common to the whole equation of the left hand side. Further separating the equation, you get x is equal to 0 to x is equal to a dx, you have to integrate it, and in the second x is equal to 0 to x is equal to a, you have to integrate cos 2 n pi by a into x with respect to dx. So, when you integrate dx, we get x, and the limit is x is equal to 0 to x is equal to a, minus integration of cos 2 theta, it will be equal to cos 2 theta, it will be equal to sin 2 theta divided by 2. When you integrate cos 2 n pi by a into x dx, you will get it sin of 2 n pi by a divided by 2 n pi by a. So, we can write it a by 2 n pi, and the limit is x is equal to 0 to x is equal to a, this will be equal to 1. Now substitute the limit, it is a minus 0 minus a by 2 n pi sin of 2 n pi by a, x is equal to a, and sin of 2 n pi by a, x is equal to 0, and that will be equal to 1. Now further solving the equation a square by 2, what it is, a minus 0 is a by 2 n pi. If you take this value sin of 2 n pi by a into a, this a cancels out. If you give n any value if you give n any value from 1 to whatever value you take it, sin of 2 pi into multiple of that number, the sign value it will be equal to 0. Sin 2 pi is equal to 0, and here if you multiply the theta value by 0, any value multiplied by it will be 0. So, sin of 0 it will be equal to 0. So, this value it will be 0 and this value also it will be 0. Sin of 2n pi by a into a it will be equal to 0, and sin of 2n pi by a into 0 that will be also equal to 0. So, what we get, a square by 2 into a minus 0 is a, and the either value, the whole value, it becomes 0. So, you will get a itself, a square by 2 into a, it is equal to 1. So, a will be equal to root 2 by a. So, if we substitute in the function psi n, a value it is root 2 by a sin of n pi by a into x. Psi n is equal to root 2 by a sin of n pi by a into x. So, this equation we call it as normalized wave function, and already we have established the value of En, that is equal to n square h square by 8 ma square. Energy eigen function. Psi n is equal to root 2 by a sin of n pi by a into x. This equation is known as normalized wave function, and En is equal to n square h square by 8 ma square. It is the equation for energy eigen value. So, substituting the value of n and either values, you can find out the energy of a particle. And if you substitute this side, the value what it is given for width of the well and sine of the value what you have to take out, you can evaluate the value of psi n. Thank you.